Welcome back to the Punny Math Teacher. Today we're going to be factoring by grouping, and if we have time and if I remember, I'll do an example at the end of factoring by logic. So make sure you're practicing and you're pausing the video and seeing how is she going from step 1 to step 2 and actually processing it and thinking your way through it. The more you actually get it into your head to understand, the better you will be at this and the quicker you'll catch on when you're practicing, because this concept you need to practice a whole bunch for it to come naturally. So this is our last objective, was to factor polynomials by GCF. You've already done that. Greatest common factor grouping is today, and then I might do a bonus example on logic. But if you want to, you can always look up different ways with logic and just guessing and checking. It's just a lot of guessing and checking and experience to know what to guess first, so you don't have to spend so much time guessing and checking with it. So I call it logic because it's just taken a lot of time with practice, and I've done it for years, so I can do it much quicker. And then comprehension questions, we are going to be making sure you look at your Wiki-type blog for how to factor and why we even want x-intercepts, because we're going to get there in the next set of notes to how to solve a quadratic using factoring. So we are on our table of contents, but we are on the back side. And we are now on factor by grouping, which is 50. So if you want to flip to that page with me, page 50. Factor by grouping. Let's do green. I don't think we've done green in a while. Okay, so we are supposed to remember that we are working with standard form. So factor by grouping, you're going to be factoring a lot of quadratic trinomials. So your degree is going to be a 2 and you have 3 terms. So standard form will be ax squared plus bx plus c equals 0. So remember this equals 0. If it does not equal 0, then you need to figure out a way to make the right hand, or left hand if you switch it, one of the sides to just be 0, so that the other side of the equation does follow this pattern. So once it's in standard form, we will follow these steps, and we are going to do an example as we work through the steps. And at the bottom, I will have 2 other examples for us to practice this technique on. So our first step is going to be multiply, because if you want to abbreviate, use multiply the a and the c. So we're going to start with 2x squared plus 7x plus 6. Now, for this example, there is no equals 0. That's okay. So we are going to get into solving by factoring in the next set of notes, and that's when we have an equal sign, because we can solve equations. We can still factor expressions. So if you're given an expression, hunky-dory, a-okay, just make sure it looks like ax squared, then a bx, then a c, all stuck together. And then if I wanted to solve this at the end, then I would just tack on an equals 0 for this expression. So just know that if there's no equals 0, that is okay. So I need to figure out my a is 2, my b is 7, and my c is 6. Make sure you understand how to find those 3 values. If you can't, pause the video, see where they line up, see where they're coming from with the form to the number. Recognizing those readily is going to be really helpful. Okay, and I'm going to multiply. So I need to multiply the a and the c, so that makes 12. Notice a times c. And I am also going to rewrite my b, just to make that more clear, that we do need a, c, and b. B, we just took it straight from the expression. Okay, and then step 2 is to find 2 numbers that multiply to AC and add to B. So I need to figure out 2 values such that some number times some number is going to equal 12, because that's my AC, but those same 2 numbers will add to make 7. Now, we could do infinite number of numbers, amount of numbers to add to 7. I could do 100 plus negative 93. That would make a positive 7. I could do 10 with a negative 3. That would make positive 7. So there are so many different combinations to add to 7 that the best limiting factor is to start with the multiplication. So if I have 12, what pairs of numbers can multiply to 12? We have 1 and 12, 2, 6, 3, and 4. That's it. Those are the only 3 pairs of numbers where we could have infinite number of pairs to make 7, when adding, I can only have 3 pairs. There could be some negatives and pluses in there, positives in there, but I only have these 3 pairs plus whatever signs are on them to multiply to make to 12. So, of these pairs, which ones could I have positives or negatives on to add to 7? 1 plus 12, not 7. Negative 1, negative 12, that's not going to help me. 2 and 6, well, that makes 8. We're getting closer. But a negative 2 makes 4. Negative 6 would make a negative 4. Negative both would make negative 8. 3 and 4, hey, a positive 3 and a positive 4 multiply to make positive 12. Awesome. And they also add to make a positive 7. Even better. So our magic numbers will be positive 3 and positive 4. Now we're going to use those two numbers to rewrite our original expression using those numbers to replace our b, specifically bx. And I'll zoom up there so you can see it. Okay, so I'm going to rewrite this. I'm going to keep the 2x squared. I'm going to keep the plus 6. I'm going to change color just so it's more obvious here. So I'm going to put plus 3x plus 4x. All right, I changed color. It doesn't actually matter. You could put plus 4x first and then plus 3x. If you want to practice that later and see how the process works, go for it. It's a great challenge. So the 3 and the 4 came from these two magic numbers. They're not really magical, but they're mathematical. And then the x is because what is 3x plus 4x? 7x. So we're taking this 3-termed trinomial into a polynomial. There are 4 terms now. This is not simplified, but there are 4 terms now. So I can group them. That's why it's called factor by grouping. I need enough terms to actually group it. So I'm going to have one group, and I'm going to have a second group. And notice that all I'm doing, I'm keeping the first and last terms, the ax squared and the c. I'm just splitting this bx using these special numbers that we found. They have to follow that pattern, okay? So now we are going to actually group and factor out the GCF. Okay, and we are going to then, after that, I want to also say, we are going to factor out the last GCF. So you have to factor out your GCFs. That's why we did page 49 of notes first, because we're going to factor this out twice. So this is our first group, and this is our second group. Notice this positive goes with that 4x. Okay, so if it's a negative, that also goes with the 4x. So this is group 1, and what is the GCF of this first group? 2x squared and 3x both have an x in common. Now if we divide by x, we will end up with 2x plus 3. Now I want you to go back, pause the video. If you distribute this x through, do you end up with 2x squared plus 3x? All right, second half, 4x and 6 have a GCF of 2. Notice it's a positive 2. I'm putting that plus sign there. It is a positive 2. So I'm going to end up with 2x plus 3. If I distribute this 2, do I end up with 4x plus 6? Pause here. You need to understand how I went from step 3 to step 4. If this makes no sense, ask someone else to figure out what happened and rewatch this video with you. Going from 3 to 4, I'm factoring out the GCF of group 1, the first 2 terms, and group 2, the second 2 terms. Now, for our second step of GCFs, actually I'll use black pen. And I need to make sure that it can work. There we go. Okay. So for this second step, notice that 2x plus 3 and 2x plus 3, both of these quantities are the same. If they are not the same, you did something interesting. So this is one of your check steps as you go to make sure you're doing it correctly. So you have 2x plus 3s. Those are the same. We know we're good. Now, because they are the same factor, and it's actually the greatest amount of same factors they have, so this is their GCF. So I'm going to factor out the 2x plus 3 from this first term, which means I'm left with x. I'm going to factor out the 2x plus 3 from the second term, and which means I'm left with a positive 2. I want you to think about where this came from. So we started here, we started from 3 terms. We made 4 terms, so we had 2 groups. In each of these groups, we divided out or factored out the GCF from each group. Now, that leaves us a same quantity behind. Because it's a same factor, I can factor out that factor, and now I have x plus 2. So if I distributed this down, so go back to your multiplying polynomials, if you used your area model or used the rainbow method or whatever you want to call it, if you distribute this back through, do you end up with this? Or do you end up with, even a simplified version, the original expression? You can always check yourself when you are factoring. Yep, you can always figure out if you have the correct answer or not. And that's it. Woohoo! Okay. If you switch the 3 and the 4, then you most likely would have x plus 2 come first and then 2x plus 3. Doesn't actually matter, but if you want to go try that, put a 4x and then put a 3x and see what happens. Okay, so we are going to do 2 examples. So this first one is 2x squared plus x minus 6, and the second one is 4x squared minus 9x plus 5. All right, so I'm going to do both of these in grouping, and then I'll do example 1 in logic probably. We'll see how that works. Okay, so for grouping, I need to know my AC, which is negative 12. My B is 1. Remember, if you can't see that coefficient, it's a 1. And I would recommend you watch this video twice, just an FYI. Okay, so I need to multiply to negative 12, but add to 1. Well, hey, we already have a chart. Woohoo, there's just 12. Now, because it has to multiply to a negative, I know that one of these numbers in the pairs has to be negative. To make a 1, 3 and 4, but 3 can be negative, because negative 3 and a positive 4 gives me a positive 1 when I add. So I'm going to rewrite this. I'm going to use pen, actually. It's nice and skinny. I like it. So I'm going to have a negative 3x. Actually, I'm going to do 4 first. I'm going to have positive 4x minus 3x minus 6. Okay? And I am purposely doing this because I want to show you 2 different things. So in this first group, their GCF will be 2x. So notice that there is a coefficient there. That is A-okay. It can be with it. That is their GCF. If I have 2x squared and 4x, that's the greatest common factor they have is 2x. And now when you have a group that has a negative in the front, this negative must go on the GCF. It doesn't matter if the 6 is positive or negative. This negative must go in front because that negative was there. All right. Otherwise, this won't work. Because I did that, and they have a 3 in common, I'm going to have an x plus 2. Now, notice if this had been a positive, this would have been a negative, and they would not have been the same quantity. By making these negatives match up, if you see a negative here, it's a negative there. If you see a positive up there, it's a positive down there, okay? Those signs have to match. If they don't, the inside quantities won't match, and so step 5 won't work. They have to be the same quantity, so step 5 will work. And that means my final answer is x plus 2 multiplied by 2x minus 3. Boom. Okay. Actually, I'm going to show you logic here, and I'll start logic on example 2, but then I'll finish with grouping. That way we'll do both. Okay? I'll do it that way. Okay. So for logic, we know we're going to end with with 2 polynomials, okay? And I know that the 2x squared is this first rainbow. That's why rainbows work. So if you're doing the area model, the logic may not make as much sense if you like the area model. But if you like rainbows, logic makes more sense. So I have 2x squared. So what times what makes 2x squared? Well, typically we have an x and an x, and 2 times 1 makes 2x squared. So I know my 2 factors have to have one with a 2x in front and one with a 1x in front. And then what multiplies to make 6? Well, I could have a 6 and a 1. I could have, those could be switched spaces. I could have 3 and 2. Okay, so looking at this, 2x, in my head I'm thinking which ones are positive, which ones are negative. So I'm guessing and checking. But because I've forced this, the first and the last rainbows to be the same, I'll put a negative and a positive. Why not? And a negative and a positive. Because I forced them to be the same, then I know that I just have to only check, I guess I'll use pink. I only have to check these 2 rainbows. It makes kind of like a donut shape. Okay, so I need to check, is 6 minus 2? That's 4. That's not what I want. What if I switched them? So that would be If I switch them, that would be 1 and 12. That's not going to work. And even if they're negative, 1 and 12 and 6 and 2, they're not going to get me to a positive 1. So I know that one, boom, out. The next one, 2 and a negative 5. Well, it's a negative 3. But what if I switched it? What if that's a 3 and that's a 2? That's a 3 and that's a negative 4. Hey, 3 and negative 4. That makes negative 1, but that means I'm on the right track. So I can have a 2x, an x. That means the 2 is in the right spot, but it should be positive. And the 3 is in the right spot, but it should be negative. So that's logic. It's a lot of guessing and checking and really ugly work, but sometimes it's faster. So if I did example 2 with logic, I know that it's either going to be a 4x and an x, or it could be a 2x and a 2x, because those will make and give me 4x squared. So these are logic, and this is grouping. Then I know it has to be 5 and 1. Okay, and let's see, I need to get a negative 9. So this is a positive 5, but because I need a negative 9, that tells me I need 2 negatives. So they're both subtraction. So this is negative 5, negative 4. Oh, that's nice. Okay, negative 10, negative 2. That's not going to work. But I already got it here anyway, because that's negative 5 and that's negative 4, and boom, I'm done. Yeah, so logic can be really quick, and it can also be really slow. If I did grouping, my AC would be 20, my B would be negative 9, and the two numbers that multiply to make 20 but add to make negative 9, so 20 is 1 and 20, 2 and 10, 4 and 5, I guess that's it. 4 and 5 make 9, but they have to both be negative. So I'm going to rewrite this as 4x squared minus 4x minus 5x plus 5. I'll have 4x, x minus 1, minus 5, x minus 1. Notice that if this was a positive 5, this would not have been a negative 1. All right? And I would suggest you try this on your own and then just pause and come back, because I'm going pretty quick. But that's our goal, is to go super quick. You're going to need to know how to do this fluidly. All right, and there we have the exact same thing. It took more work, but sometimes guessing and checking takes just as much work. So it's a toss-up of what you like, and in the situation, which one's actually quicker than another one. So, all right, so that's factor by grouping. I'm sorry we're going over 15 minutes, but this is a really important set of notes, and I want you to make sure that you're actually taking your time on this, because knowing this process and understanding what each step does and why will help you so much in Algebra 1, in Geometry, and Algebra 2. If you go higher into Pre-Calc, and into Trig, and into college, like, you're going to need how to factor. It's so helpful, and it helps your logic skills so much. All right, well, thank you for watching, and have a great day. Bye.